So welcome to my talk about simplicity, how we as a three-person team can survive building and running an application. And we started with this product in 2015, so 10 years ago. And yeah, my company is just 13 people. It's really, really small. And of these 13 people, there were just 2.5 devs. So I was the half dev because I was external and I was consulting the company at Time just for 50% of my time. So we are 2.5 devs, so really, really small. And we also had an old product that we wanted to replace. Fun fact, it's still in production today, but with much fewer customers. But because we just don't want to make a real 100% replacement, so we target a different customer segment, so that's why it's still there. And we had a vision that we as a 13-person company can only survive if we reach 20,000 users. Then it's sustainable when the old product really dies off. And nowadays we are somewhere in the middle. So we are at roughly 10,000 users. So we still have to go some years probably. But luckily the growth isn't linear. The growth is better than linear. And we are still 3 devs. 2 are still the same. And now I'm 100% there. That's why we are 3 now. We were 5 for a couple of years. Company still 13 people. Also not exactly the same people, but still the same size. And we have roughly 350 customers. So we see you have a lot of small customers as well. Yeah. Our system is for tracking attendance time, project time, and for duty planning. So all the fun stuff you have in a company. Yeah. So, and we 3 developers, you have only 3 brains. And yeah, we have to know and deal with a lot of things when we do develop and operate the system. And we have a .NET backend and we have an Angular client. That means we have to know 2 different ecosystems with all the things that are in there, how you build stuff, how you test stuff, and so on. And of course, security is always very, very difficult. But we also have all the operating stuff. And so we were 3 developers, so we had all to learn that stuff. We weren't operators. And yeah, we are on Azure, because Azure makes a lot of things easy for us. But yeah, you have to know all the services, not all, but a lot of services. You have to learn how to do zero downtime migrations, because our system runs all the time. It's needed all the time, because it's duty planning. People work overnight and on weekends. Things like telemetry, service buses, all the different kinds of storages, it's just much. And yeah, Azure evolves, so all the things change all the time. So, and yeah, we had to make a conscious decision, how do we want to approach that, so that 10 years later, we can still be in that job without being burned out. And we said, we have to do all the things as simple as possible, so that they are easy to understand, easy to deal with. Simplicity is the quality or condition of being easy to understand or do, or uncomplicated in form or design. So all the things should be simple. And in this talk, I want to show you a couple of things that we did to make things as simple as possible. I struggled a bit while preparing that talk, because we do a lot of things and on very different areas, so it was really hard to get one coherent story together. So please bear with me if it's a little bit jumping around. I invented this model to talk about simplicity. On the horizontal axis, you have generic to specific. And when we build a solution to a problem, it can be a very specific solution. It's a solution for exactly one single problem. Then it's very specific. On the other hand, a generic solution, for example, the .NET framework or the Java-based libraries, they are a very generic solution to building applications. You can build more or less any application with these tools. They're generic solutions. Horizontally, we have concrete to abstract. Concrete, I can say, you're sitting in a chair. Chair is more or less concrete. It could be much more concrete. It could be, it's a gray, silvery chair where you are sitting on. That's very concrete. I could also go more abstract and say, you are sitting in a piece of furniture. Sounds a little bit strange, but I can say, yeah, you as an entity are sitting in an entity that is watching an entity talking about stuff. That's very abstract and very useless. And maybe take a moment and think about your code base. Probably you find such useless, very abstract stuff in there. These over-abstracted code bases where nobody knows anymore what it actually is. And it's too abstract. So, and my idea is that things are simple when we are at the bottom right. Things are rather specific, rather concrete. Then it's easy to talk about these things. They are probably much easier to understand than when we are on the other side, where the things are generic and abstract. I think there the things are typically hard to understand. And a couple of years ago, there was this time when all the big companies decided we build first a company-wide framework, and then all the projects can be built very, very quickly. Yeah, but building a framework is on the top left. And all these approaches typically failed because it was just too hard to understand to build such a framework when you want to start with a framework. I think nowadays it's called developer platform engineering. I think it's probably the same bad idea. So, yeah, nice notification. Now you know what I watch on YouTube. Or maybe it was from my children because they use the same account. I don't know. We should start at the bottom right, where things are simple. Rather concrete, rather specific. But we add stuff, we add features, and the code base grows and grows and grows, and we don't want to have a lot of very specific concrete solutions. Sometimes we want to add some some abstractions, some genericity, because it's just, yeah, it's still a simple solution, but I can solve several problems with that. It just reduces the amount of code I have to write, for example. So we add and add and add, and sometimes it happens that we step out of the happy zone. And the only way back, in my experience, is to do a lot of refactoring. So refactor every day, a lot of small refactorings. And if you are lucky, many small refactorings lead to a few big impact refactorings. So you worked so much on the solution and the problem that probably Sunday afternoon on a walk, you have a great idea. Oh, it could be done so much simpler. Let's change that, make it simpler, and go back into the lower right to a simpler solution. For us, in 10 years, we roughly had 10 big impact ideas. So daily refactoring led, in average, to one great idea per year with 3 developers. Doesn't happen that often, but they dramatically reduce complexity in your code. So, next thing is, we should only add stuff that is really, really needed. We shouldn't add stuff because we heard it at the conference, or because it's cool, or because of our CV. We shouldn't do that. And one example I took from our code is we use event sourcing. Anybody uses event sourcing? Anybody doesn't know what event sourcing is at all? Yeah, sadly, I don't have time to explain it, but the idea is that we don't save the state of something. Now it's 17. We store what happened and end up at 17 if we replay or project all that events one after the other. And that's a really good fit in our domain of attendance time tracking because everything has to be audited. Everything needs a history. How did I work to get there? And one thing is that we learned that our users make a lot of mistakes. And any mistake that is possible. So with event sourcing, it's really easy to undo stuff. You just compensate or remove the events at the end of the event stream. That's a really nice feature for us. But I read and hear a lot that event sourcing is so complicated. And yeah, when you do all the stuff that is around in the space of event sourcing, yeah, then it is really complicated. But normally, we start just store the events. And when you need the state, then project them. It's almost as easy as create, read, update, delete. Get some events from a database, project them, done. Really simple. When you do that, and that's how we do it for most of our data, sometimes you get long event streams. So many events for a single thing. And then projecting them can get slow. But there are some tricks how we can pull things out from one single event stream into multiple event streams so that you have only short event streams. And then you can, when you need state, just project it. Easy. And then maybe you need to add a read model. But we only do that when you have queries where we need the state. So we make a query on something in the projected thing. We can't query for the events directly. Only then we add a read model. Because a read model adds complexity. You have to update the read model. You have to do it in a consistent way. You have to decide, do you update it synchronously because the user wants a consistent behavior, or do you update it asynchronously, and on and on and on. It gets complicated. And then, of course, it's event sourcing. You always have to do CQRS. That was ironic. So just do the things that are really needed. Keep it simple. If you want to know more about how we do event sourcing, because it's way crazier than that, there's a link. Hint is the word bitemporal. That's why it's a little bit more crazy. So now I'm a software architect, and we think in boxes and arrows. But today it's too hot, just boxes. Our system is this black box. And yeah, we need to structure our things in a way that we can easily navigate it, easily understand it. And there's a simple trick. We put boxes into boxes. And maybe you heard that our brains, our working memory is only capable of keeping at max 7 things in memory at the same time. Just one? Yeah, one is little. Most people are around 5, but it varies. So if you want to look at something, you shouldn't put more than 7 things in it. It's the same with music notes. There are 5 main lines because it's easy to overview. And then when you only have 7 things, so the 6 things here, yeah, you just repeat it. So if you want to go into the details, forget all the big rest, just look at one box, understand that. And repeat it, and then it's a fractal. It's self-similar, it's just boxes within boxes, at most 7. So we do that in our software. We don't call it boxes, we call it the system, the subsystems, like attendance time is a subsystem, duty planning is a subsystem, because they are more or less decoupled from the domain already. And then if we go down to the single task a user can do, a user can, for example, create an activity in the project time, or she can replace an activity. These are the slices, the bottom. And maybe you have heard of vertical slices architectures. It's roughly the same idea with an added idea that the way Jimmy Boker tells it doesn't work because you have to do it in a fractal way so that it stays simple. You put slices within slices, like the boxes before. Slices within slices within slices. So the task for creating an activity or replacing activity lives in the slice, the bigger slice, manual activity. Because you have manual activities and you have, for example, multi-action activities, whatever that is. And both together are the slice activities, and so on and so on. It's an easy way to structure the code so that you find your code even 10 years later. Because you have code that we wrote 10 years before, we never changed it, but we can still find it. Because it's always organized to the tasks a user can execute. I know that's really, really fast. It's just an overview. I want to give you some ideas. You can talk to me afterwards if you have questions. So, coming to the deployment, so we have roughly 350 customers, above closely to 10,000 users, and our main architectural problem is that all these 10,000 users come to work roughly at the same time, and they go for lunch roughly at the same time. So our request per minute graph over the day looks like this. Almost nothing in the night, almost nothing in the morning, then it's lunchtime, and in the evening there's not so much that heavy a burst. So we have to find an architecture that deals with these bursts, because then all the users are there, and if it's slow then all the users say the system is slow all the time, because otherwise they don't use it. Do I have time for one anecdote? Do I have time for one anecdote that takes 2 minutes?
Yes.
Okay. We once had the problem that we were DDoSed by our own users. Because we had a problem with an index in the database that made one query on the initial screen slow. And our users were used that our system is very responsive. So it got a little bit slow, exactly. Users to study, that's not normal. Let me press F5. And it's a single page application, so the whole application reloads and all the data you can see is reloaded. Of course, that's very, very fast. When everybody does it at the same time, repeatedly. So we had to take the application offline for 1 minute so that now nobody pressed F5 again, and then it was fast again. So we had this really threshold that we shouldn't reach. And afterwards, we did some stuff in the deployment so that shouldn't happen anymore. So our system, of course, is this simple. So yeah, excuse me, but it's really boring because it is simple. But that's a good thing. Boring stuff isn't complicated. We have a front end. It's built in Angular. Talks with HTTP to our backend, which is ASP.NET Core backend hosted in Azure Web Apps. With auto-scaling, because just scale it automatically, Azure. We don't have to do that by our own. And we have Azure Functions for all the things that are CPU intensive. So we want to offload all the things that are CPU intensive from the backend to the functions so that the app keeps responding quickly. And if we do it in a synchronous way, it's HTTP, and in an asynchronous way, it's a message over a service bus. Of course, functions are built for scale. That's not a problem. Then we need some storages, and we need distributed cache, Redis, and we have SignalR for notifications to the client. Also very important, App Insights, that's our telemetry solution. It's built into Azure. It's the only reason we use it, because otherwise it's not a really good tool. And we also need a scheduler for things that happen daily or weekly or monthly. That's Azure Logic App. And that's our whole system. nothing more. And fun fact is, this auto-scaling is, with 10,000 users, it normally runs on one node. During peak time, it runs on 2 nodes. And it sometimes happens that it goes to 3 nodes. So scale is absolutely no problem at all. And yeah, we can just say in Azure Portal how much scale we allow. It's just a slider, and we can go to the right much, much, much further than we are today. So even if you have these high bursts, 10,000 users, nothing. Yeah, but even so, when we started, we did something simpler. It looked like this. We just had the front end, back end, and the back end did all the stuff. There were no functions, because at the beginning, with a couple of 100 or 1,000 users, this was fast enough. And it was even simpler. And all the data was in SQL. We changed that when we got more data, because SQL is the most expensive storage you can have on Azure. Yeah. But when you have little data, it's cheap as well, so we didn't care. So what you did is, we started extremely simple and went to simple. So no Kubernetes clusters or what else, just a couple of Azure services. I will come back to that later. And regarding designing software, I have my highest top principle. That is, when you add something to the system, make sure it is easy to remove. It's the only principle I have. Make it easy to remove. Because when it's easy to remove, it's easy to change. Because you could remove it. Normally we don't do that, but you could. And if you think about how can I get rid of that, you automatically answer the questions about modularization. Should it be its own module? Probably yes, because otherwise you can't remove it. Or things like slicing, or should it be decoupled or not? If I remove that, should I remove the other thing as well? Or should they be removable independently? So you answer the question about decoupling. So I talked a lot about code, about our architecture, a little bit about design, that it should be evolvable, that it should be modular, and that you think in tasks. So every task is a slice in our structure. But I want to point out one important thing in addition, and that is the programming language. I know a lot of people say the programming language doesn't matter. I have a completely different opinion. Programming language matters a lot. Because we started, the slides before I've seen, our backend is written in C# and F#. So we switched from C# to F#. C# is mainly an object-oriented programming language with some functional features. F# is primarily a functional programming language that also supports object-oriented programming. And we switched. And we did that 5 years ago. So all the new code since 5 years is written in F#. And the reason we switched is that I talked to some F# programmers and said, hey, you should really try that. It's better. Try it. And I convinced my team that I could take one slice of our system, rewrite it from C# to F#, and I showed them the result. The decision was made in roughly 2 seconds that we would switch, because the code was so much simpler, so much easier to understand. It's based in some language features from F# that C# doesn't have. Java doesn't have them as well, so it doesn't help you with Java. And the other reason is it's composability and reusability. Functional programming is just functions calling functions. Everything is functions. You don't have to deal with, I have classes, objects, and methods, and when I have a method, I have to have an instance of an object that I can call a method. That's much harder to compose. But you probably won't believe me until you have seen it for yourself. Yeah. If you just know object-oriented programming language, you probably can't imagine how it is to write in a functional or more functional programming language. Don't try Haskell. It's too hard. It's too functional. If you can, great, I can't write Haskell. So, yeah, that was a very important switch for us for more simplicity. But if you want to achieve peak simplicity, you can't just talk about code and architecture and design. You have to talk probably about everything, and I picked collaboration tools and process. First, about collaboration. We work in a very dynamic way. So when I pick a task, I think for myself how best to tackle that task. Can I do that on my own, solo programming? Typical one feature more, not that difficult, I can do that on my own. Sometimes I need a sparring partner or somebody that challenges my ideas or my design or reviews my codes. Then we switch to pair programming. And sometimes, yeah, we're just 3 developers, so pair or mob programming isn't that big difference. But sometimes we need all the brains we have. Sometimes we also include one of our domain experts to sit with us so virtually sit with us in the mob. And important is that we have the attitude that the other's problem is more important than mine. That's really important because otherwise that doesn't work. Because if you just have lone wolves, everybody codes for him or herself, and you don't help each other. So helping is more important than getting my own stuff done. Then work visually, visualize all the things. It's just easier to communicate. If you communicate, then do it person to person. Doesn't have to be in reality face to face, but don't talk over tools. I don't mind, video conferencing is okay, but don't write the ticket and somebody else reads the ticket. Talk to each other. Maybe write a ticket to summarize so that you don't forget, but talk person to person. Communication is much richer, much better, much less misunderstandings, simpler way of working. And the last thing is, you should find your language, how you talk about stuff, the ubiquitous language. And we struggle a bit with German and English. So our code is mostly in English. Our customers are mostly German speaking, and sometimes meaning gets lost in translation. So that's we have some words in German in our code base because the translation just doesn't fit. But the idea is to have one single model, how we developers, the code, our business experts and the support staff talks about stuff. We all should use the same terms. Makes it much easier. That's how we are organized. And my point here is that you should organize your company around the product you want to provide, not the other way around. So you see no hierarchy. There is a hierarchy because I need to have a boss. My boss is one of the business experts. We are the 3 developers. We have 2 business experts that help us with the really complicated domain stuff. Because after 10 years, we as developers are somewhat domain experts as well. We have 1 salesperson. We have 5 people that build the bridge to our users and customers. They support them, they introduce the product at their site. So the users mainly talk with these 5, sometimes with these 2. And we have an owner and we have an admin person. So everything is built around the product. So processes. Yeah, fun topic, processes. The most important process is the process to remove processes. Very important process. In general, we say we should have as little overhead as possible. Yeah, obviously. But it's really hard to do. An example is we have only 2 recurring meetings per week. Monday morning, we plan the week. On Friday morning, we devs sit together and do something together. Show new stuff, discuss some topics. The rest of the time, I'm coding or thinking or designing, unless there are some ad hoc meetings. That's always possible. And the nice thing is, if your calendar is that free, you always have time to do a meeting right now. And that makes working together really great. Maybe not now, maybe in 5 minutes, but you get the point. And one point I wanted to mention is testing. We think a lot about return on investment on testing. So we want a quality product. I think we have a quality product. We don't have that many bugs in production. And it's about numbers, and our users care about their numbers, how many minutes they have worked and how many vacation days they still have. So it's really important these numbers are correct. And so we like TDD, test-driven development, but only where it fits. And it fits mainly for business logic, and not for the rest. But yeah, I know, I shouldn't say that, but that's how we do it. Another thing is approval testing. And yeah, I wrote acceptance testing, which is wrong. We don't do acceptance testing, we do approval testing. So I made a feature out of it. Because approval testing is that you run a test, it generates some output, you approve it, that it's correct, and on every next run, the test compares what it gets with what you approved. So if it's the same, it's green. If it's something different, it fails. And the point I bring this is testing is a lot of effort. Maintaining tests is a lot of effort. So the simpler thing is to remove tests with something better. So if you have a really good compiler that tests many, many things, if you have a good programming language where there are no nulls, you can't have null reference exceptions. That's better than testing. Or things like a design where wrong states can't happen because you can't model that. You can't have a wrong representation. It's much better than testing. It's much easier to maintain. Also, something that is important is how you make decisions in your team. So you get good and simple decisions. It's really, really difficult. Or processes should have almost no handoffs, because every handoff introduces complexity, misunderstandings, added communication, and added problems. The idea for us is when a customer or the user has a good idea, it should be in production as fast as possible. That's our main goal in all the processes we have. Ideally, this is 1 hour. Of course, if implementing the feature is more than 1 hour, that's not possible. But if it's a simple idea that we can build in 20 minutes, this should be an hour. And we achieved that. We achieved that because we invented our own way of working. So obviously, I don't have time to explain it. But again, there is a link. Or just Google caretaker model and Urs Enzler. You will find it. It explains how we work. And if you want the slides, just email me. I'm Urs Enzler. I'm digitally unique. I'm really easy to find. I'm not sure whether that's a good thing or a bad thing yet, but for you, it's a good thing. So, last topics, tools. Because we are DevOps. I know originally DevOps wasn't about tools, but my experience is DevOps today is just tools. I know, we try to make a difference, but yeah. The tool vendors won, I think. I've used tools that are as high level as possible. So we don't have time, we don't have the capacity to deal with details. We want as high level tools as possible. Of course, there are trade-offs. If you have high level tools, you can't control details anymore. But for a three-person team, that's the better trade-off side. So, and we want to have tools that are managed. Somebody else runs them for us. So that's why we are in a cloud on Azure, and Microsoft runs our stuff, most of our stuff. And we just have our code, we can throw it at Azure, say, just host that code for me. Not my problem anymore. That's still my problem, but I can. They keep it running, and if something isn't running anymore, we get an alert. And we also prefer tools that are rather stable. Not dead tools, tools that evolve, but that evolve at a sustainable pace for us. Because if you have the problems like web development, where things change hourly probably, it's really hard to keep up. It's a lot of work just keeping up. So we prefer rather stable tools. .NET is a rather stable tool. Angular is nowadays a rather stable tool. You can focus on features, not on keeping the tech up to date. So to finish up, you probably know KISS. Keep it simple, stupid. That's really, really great advice. But it's just step one. Step two is make it simpler over time. Because over time you will add new stuff, more stuff, and our brains don't get better, so the stuff that is there needs to get simpler and simpler and simpler over time. You can do that with refactoring, re-engineering, or you have to with rewrites. Or if you look at processes, talk about your processes, look for continuously improving everything you do. So you can every day a little bit, work every day a little bit in a simpler way. That's it for me.